to work today. So we have the moles. Is it showing? Okay. We have the mole. We'll talk about it. We have the mass number or the atomic mass. We'll talk about the normality. We'll talk about the molarity. And we'll talk about molality. We'll talk about percentage purity. I'm just going to explain these things in a glimpse. Percentage purity. Percentage purity. We'll talk about molar concentration. Okay, that's molarity. Okay, what could be there again? What could be there again? Okay, let's say we have this few information now. At least we should explain this one first before going into stuffs. So now, the first thing is mole. So what is mole or what is number of moles? When we say the number of mole of this thing is this, what do we mean by that mole? Absolutely. Yeah. Kingsmith will be recording. I haven't seen him. Kingsmith. Amazing. Kingsmith. Perfect. Thanks for yesterday's work. Thanks for yesterday's work. That was very good. It was very good. Yeah. So the mole only means the amount of elementary entities that is inside a particular atom. So that means the amount of that atom. That's what mole implies. That's just what it implies. Mole is amount, and it's the basic unit for amount. We do say that mole is a fundamental quantity. It is not derived from anything. It is a fundamental quantity. So now, this mole now has the unit of MOL, mole, mole. So I'm going to write mole at the middle here now, and I'm going to write about 5 formulas you can use to calculate moles, depending on the parameters given to you. So if this is the parameter given to you, then you're using this parameter. If you are using this formula, if this parameter is the one given to you, you're using this formula. So we have all these parameters here. We have the molarity, everything. We'll be explaining that. So now, mole can be gotten by doing mass over molar mass. That's one formula to get mole. So, okay, Mr. Beatrice, speak out. You raise your hand. Speak out, Mr. Beatrice. Okay, I think he has nothing to say. Don't just unmute if you have nothing to say, please, Mr. Beatrice. Okay, now. So mole can be gotten from this. Mole equals to mass over molar mass. Another thing is mole can be gotten from the volume and concentration. So, but it's not ordinary concentration. Concentration in mole per dm cube times volume. This is another formula for mass. So another formula for mole rather, another formula for mole is also number. So number of particles. It might be molecule, it might be number of atoms, it might be number of molecule, it might be number of ions. So all over Avogadro's constant. Who is going to write the Avogadro's constant out for us? Avogadro's constant. What do we mean by the Avogadro's constant? Is there anyone that will write it out for us? The Avogadro's number. I suppose someone is writing it already. Avogadro's number. Anyone?
What should I say?
I think it's 0 times.
Sorry, sir. I want you to share the
Let's write
screen.
it out so that I don't write that we'll see all those things.
Hello, sir. Please, can you please share the screen?
Hello, good evening. Can anybody hear me? Because I'm not hearing, I can't hear any voice. Oh.
Yeah, we can hear you, but I think is the one is the
Can hear you,
sound.
sir. Thank you.
Can hear you.
Please, who is anchoring the today's this thing now? Who's anchoring today's class?
Just wait. The person is anchoring already. You're just joining. I think it's having network issue.
Yeah, hello everyone. I just came in. Sorry, are we finding how to calculate the number of votes? Sorry, can anyone help me with it? What topic for today actually?
Can you
What's
please
the total of what?
unmute yourself? We can't hear you.
Sorry, mistake. I didn't unmute it and I'm talking. Sorry. That was a mistake. Okay. So I said the topic we are taking is actually quantitative analysis, but I can't just enter this thing. You might have known about it before, Mr. Jedediah. You might have known about this before. So that's why you're not, you understand me? So, but some people might actually not know about it before. That's why I have to come from scratch. Some people love basic knowledge. Like they want to know it from the scratch. Don't worry, we're going to take our time here and everything will be covered within the schedule. So we continue now. That's mole. Mole has been cleared. Mass number. When we say mass number is we call it atomic mass too. It is the sum of the number of protons and the number of neutrons present in an atom. So I'm going to define these things. I'm going to define them. We can't just be entering and be working anyhow. Some people might not even know their basic foundations. So I can't just do like that. And someone will now waste his time without getting anything. That's not part of it. So now mass number is equal to number of protons plus number of neutrons. Now take a good look. You will not be asked to calculate the mass number by using number of protons, and they'll give you a number of protons, or maybe some few questions. That will not be this level again. So now I had someone saying, okay, let me say it this way. Now, mass number is equal to number of proton plus number of neutron. The proton is in the nucleus of an atom, and the neutron too is an atom. So both of them constitute to the mass of that atom. Rutherford model of an atom says that the atom is a sphere the atom consists of a positive core nucleus, that is a massive core nucleus with electrons embedding, revolving around it. New Rutherford planetary motion. Electrons revolving around it, the way the planets revolve around the sun. So now he said the most mass of the atom is concentrated at the nucleus. That means the mass of the atom consists of the proton and the neutron. Those are the two things inside the nucleus. Electron is extranuclear. It's not inside the nucleus. So now, these two things now added together is going to give us the mass number of that thing. So number of protons plus number of electron is what is going to give us atomic mass. Not atomic number, atomic mass. It is also known as the mass number. Atomic mass or the mass number. So now, hydrogen has no neutron in its own nucleus. Hydrogen, it has no neutron in its nucleus. The three isotopes of hydrogen, none of them has neutron. So, but it has one proton. I'm talking about the first isotope of hydrogen. That is protium. The second isotope is deuterium. And the third one is tritium. So as for the first one, that's our case study now. The first hydrogen atom, the first isotope of hydrogen atom, the one that exists mostly in the atmosphere, H1. So it has the atomic number of 1 because it is the first element in the periodic table. I told someone this afternoon that the atomic number is just the serial number. Atomic number is just the serial number. The first element in the periodic table has the atomic number of 1. The 10th element in the periodic table has the atomic number of 10. The 50th element in the periodic table has the atomic number of 50. That is the logic. The 100th element in the periodic table has the atomic number of 100. So, but many people think mass number is when you multiply the atomic number by 2. That is totally wrong. In some cases, it is right. So, mass number consists of the proton and the neutrons. When the proton and the neutron are the same thing, that's when you think your mass number is atomic number times 2. Because atomic number is always equal to the proton number. There will be recording of this thing, when maybe it's sounding complex. Then King Smith is doing the recording for us. It will be dropped in the book. So you can surely get it. And getting it from YouTube, it's very easy. I really appreciate the man's work. So it was okay. So you are going to get it without any problem. So now, mass number, as we defined, was it has been defined that number of protons plus number of neutrons. That is the logic. So explain mass number. The next thing we want to explain is what we call normality. So this normality, they are no more using it as normality. Yeah, they don't use it as normality again these days rather. So it is known as mass concentration. Mass concentration. So what do we mean by the mass concentration? That is concentration in grams per dm cube. So I think when we went for the practical, some people were confused in some ways the way the lecturers were talking. dm cube is the same thing as liter. 1 dm cube is the same thing as 1 liter, while 1 cm cube is the same as 1 milliliter. Don't be confused in any way. Take a good look. 1 dm cube is the same as 1 liter, while 1 cm cube is the same as 1 milliliter. So normality is equal to the mass of that thing, mass of the compound. Normality of the compound is equal to the mass of the compound over volume of the solvent that has the compound in it, that is in which the compound is being diluted. So the volume in dm cube, note that mass of the compound over the volume of the compound in dm cube. This is another formula. So normality, I said they call it normality. It is actually mass concentration these days. Okay, Mr. Sticks. Oh, okay, yes, removed it. They call it normality.
I'm sorry.
Okay.
Yeah, just stay there. I want to write the formula of normality, sir. Okay.
People don't call it normality again. It has been long I even saw it as normality, but I saw it in our first material too again. It was normality.
So what is it called? What is it called?
It is mass concentration. Mass concentration these days. Mass concentration. Do you understand?
Yeah.
Since Alipak has come,
thank you.
Okay. So now that is for normality. The next thing we want to say is molarity. Molarity. So molarity is very simple. That one is just amount of mole in dm cube. You know, normality was amount in grams in dm cube. So molarity is amount in mole. Amount in moles. That means number of mole in volume. So volume in dm cube. It is not volume in cm cube. You have to use your volume in dm cube. So this is molarity. This is molarity. So I don't want us to waste much time again on defining it. That's why I'm making it snap now. So now you should not make mistake. Normality is mass of the compound in volume, in one volume of that thing, in dm cube. Molarity is the number of mole of that something in one volume of that thing in dm cube, or the thing that consists of it, that contains it. So molality, this one is amount in mole. So number of mole in kilograms. That means the amount in mole over the mass of that thing in kilograms. So the unit for molality, because of that, the unit of normality is going to be mass, that is gram, per volume, dm3. So grams per dm3. That's why we call it concentration in grams per dm3 or mass concentration. The reason you are knowing it is mass concentration is because of this gram that is before it. Gram means mass. Gram is the unit of mass for small things in chemistry now. This. So now, this one is mole per dm cube. Mole per dm cube. That is molarity. Mole per dm cube. They write it as capital letter M2. Okay, Juliet. Miss Juliet.
Okay. Good evening, sir.
Welcome.
So my question is that yesterday you mentioned that the unit of that anything that is being weighed in chemistry, that the unit is a kilogram, and now mass is gram. So I'm a bit confused.
Don't be confused. The issue is that the SI unit, that is the base unit, is kilogram. But here, in calculations, hear me now, calculations involving stoichiometry, many things they use here is grams. So you're not converting it to SI unit, which is kilograms. The SI unit basically, normally, is kilograms. But when you are doing calculation in this one, don't come and convert it to kilograms. So because, why? It is because the thing are very small. Do you understand me? Some chemical will just be a chemical that will not fill your hand completely. Chemical that will not be able to fill your hand completely. So, and when we say 1 kilogram, that you know what 1 kilogram is now.
Yes, sir.
So 1 kilogram, 1 kilogram is weighty. It is heavy. So, but this one now, 1 gram or 20 grams, they will say this one 10 grams, like all those soap we always buy, detergents, 20 grams. That one, if you are expressing it in kilograms, it will be too small. You will be having too much decimal points. That's why they are using grams for it.
All
You
right.
understand?
Thank you, sir. Yes, sir.
My pleasure. Okay. So molarity is mole per kilogram. They are using in 1 kilogram of that thing. Mole per kilogram. That's how this one comes. So mole per kilogram. Molality is the amount in mole. Calculation doesn't come with this one most times. So I don't even calculate anything. So I think I covered the thing we have here. So when we now say percentage purity, something inside has amount or mass of pure part of that substance over amount of overall of that compound multiplied by 100. That is percentage purity. We have a question to treat. Prodigy. So let me put it well for those that it will be beneficial to. Prodigy. Prodigy don't come out. Very question now. Prodigy, are you lonely at the top? Oh, Prodigy is not here. That's serious. Oh, who's going to help us? The question I sent it to him already. Okay, Miss Amina, I'm sending you.
Yes. Good evening.
Good
Please,
evening.
about the percentage purity that you said is the amount of pure over amount of overall. Is it the same
Amount of
thing
overall compound.
as the amount of impure multiplied by 100?
Mm.
Is the same thing with amount of pure over amount of pure.
Amount of impure. You can call it impure. Since the overall is impure, you can call it impure. It's the same thing. The formula is the same thing.
Okay,
Get it?
thank
It
you.
is the same thing. Since you can call the overall thing that is not pure, since it is not impure before, so it is the same thing. Don't worry.
Okay, thank you.
It is the same thing. You can use it out the two. Okay. I have a question here, but I sent it to him, so we'll be able to show us or type some things out for me. But I think I'll have to look for it myself. Okay, I'm sorry. This is it. You should be seeing this well now. Are we there? So
Yes, sir.
I don't know if there is a man that do write something very fast. Okay, yeah. So I think it's going to happen. Please mute your mics. So the question says, in a titration experiment, this is the first question of the solving. Before, or should we use the other one? Let's take these little questions first. So we are taking the little questions first. How many liters of 10 M, that is capital letter M, mole per dm cube? How many liters of 10 M hydrochloric acid, that is HCl? How many liters of 10 M hydrochloric acid, 10 molar hydrochloric acid? How many liters of 10 molar hydrochloric acid, that is 10 mole per dm cube hydrochloric acid, are needed to make 4 liters of 0.4 molar solution? Are needed to make 4 liters of 0.4 are needed to make 4 molars of 0.5 liters of that solution. So 4 mole per dm cube. 4 liters of 0.5 molars of that solution. Okay, has anyone written the question out?
Come again.
Okay. I said, how many liters of 10 molar, that's capital letter M, it means moles per dm. How many liters of 10 molar hydrochloric acid, right, HCl, are needed to make 4 liters of 0.4 molar solution? To make 4 liters of 0.4 molar solution. Did you get it now?
Yes. Thank
you. Did you type it out? Thank you, K. Thank you, Mr. K. Okay, this is the question. Everyone can take a good look at it from the chat. This is the question. So now, we're going to solve this by saying how many liters of 10 molar of hydrochloric acid are needed to make this. That means we are looking for the volume of that thing. We don't know. It's the volume we are looking for. So the volume is what? We are given the concentration in moles per dm cube like that. That is 4 molars. That's 4 moles per dm cube. And after the concentration too, we are given 10 molar, sorry, 10 molar. I have to be minimizing, that's why. We are given the second equation that should be made. So 4 liters, that is new volume, V2, equals to 4 liters. And C2, which is the second concentration, is 0.4 moles per dm cube. So what we mean here is that they are going to take, okay, Mr. Raphael.
Don't worry, go ahead. It was before. Thank you.
Okay. I had to minimize. I was minimizing to get my own question myself. I had to minimize it inside the screenshot. Okay. So I've written the parameters out now. So volume, in this case now, we are looking for the volume of that stock solution. The stock solution is the concentrated solution that we are diluting to get another solution. We are getting another solution from it. That's the stock solution. So the volume of the stock solution is given. It's not given, is what we are looking for. But its concentration is given. It's at 10 molar. So now the volume of the solution we are looking for, the one we've gotten, is given. The new solution we got. And the daughter solution, some people call it daughter solution. I think there's another term for it. And the concentration for that one is gotten. So now there is a formula we are going to use. That formula is known as dilution formula. So it is known as dilution formula. The dilution formula just says that C1 and C1 and V1. That's C1. We should be familiar with this formula. C1 V1 equals to C2 V2, where C1 is the concentration of the stock solution, V1 is the volume of the stock solution, C2 is the concentration of the new or daughter solution, and V2 is the concentration of the daughter solution, again, volume of the daughter solution. So here now we are looking for V1, making the V1 the subject. V1 equals C2 V2 over C1. So what is C2? C2 is gotten to be 0.4 times what is V2? V2 is gotten to be 4 all over what is C1? That is C1 is 10. So I'm writing my 10 here. So I have 0.4 times 0.4. That should give me 0.16. So I have 0.16. V1 is 0.16 liters. Don't forget your unit. I think without the unit, you might even get 0. Because it's OBJ. So please, any question about this? Any question? We've solved the question. Mr. Bitros.
Yes, sir. 0.16 liters. I don't know. Are we using liters or DM cube here?
Because your volume was given in liters.
Okay, thank you. Thank you.
4 liters. So you must also use liters. So I love you. And thank you, Jared Prodigy. We'll be using that equation later. Very soon. Or should we just make it the next thing? Okay, any questions so far? Mr. Wisdom, any question or you need from me? Any questions?
Sorry, a quick run over from the question.
What's that? You said something, Mr. Jeremiah. You said something.
Please, can you do a quick recap from the question? Just the short.
Can I what? Don't hear you.
He said, please, can you do a quick recap from the question?
Okay. All right. This is it again. The question was given to this. Listen to the question again. How many liters of 10 molar hydrochloric acid are needed to make 4 liters of 0.4 molar solution? The reason is that the acid was too concentrated. They said 10 molar. That means 10 mol per dm cube. That's very concentrated. So now they want to create a solution of a very low concentration from it, a concentration of 0.4 mol per dm cube. And the volume they just need is 4 liters.
We can't see your screen, no. We can't see your screen, no. We can't see what you're doing.
I'm not sharing my screen. This question was being read out before and it has been written out by someone. I'm not sharing my screen, please. This is what I'm showing. I'm not sharing my screen. I'm reading this out. You have the question already. You can go to the chat to check it out. Someone wrote it out for us. Take wrote it out. The first question there. The first question. So I'm minimizing to read the question out. I have to minimize. So is it possible for me to know if the thing is going or still on it? Because I'm minimizing. So how many liters of 10 molar hydrochloric acid are needed to make 4 liters of 0.4 molar solution? So they are making a new solution from that stock solution because the stock solution is too concentrated. They don't need it. They need something that has a lower concentration. So they have to make another solution. The new solution they are making now must have the concentration of 0.4 moles per dm cube. The concentration of 0.4 moles per dm cube and must have the volume of 4 liters from that concentration that they have before, 10 moles per dm cube. So now, how many volume are they going to use to prepare this thing? How many volume of that 10 moles per dm cube are they going to use? So that is the volume we don't know. Using the dilution formula again. Using the dilution formula, C1V1, that means the product of the concentration. You know, C1V1 means N1. That's number of mole of the concentration equals to the number of mole of the stock solution rather. Number of mole of the stock solution equals to the number of mole of the gotten solution. That is conservation of mass. What is at the right hand side will be equal to what is at the left hand side. So now C1V1 equals to C2V2. That means the concentration multiplied by product of that stock solution must be equal to the concentration multiplied by product of the gotten solution. So we have C1V1 equals C2V2. We are looking for V1. So the V1 we're looking for is the volume of that stock solution. The volume of the stock solution is what we're looking for. So making it the subject, right? V1 equals C2V2 over C1. We have the C2 to be 0.4. We have the V2 to be 4. We have the C1 to be 10. In our mathematics, by evaluation, we get the value of V1. So this is it. For those that are willing to write it out. Mr. Raphael.
Okay, sorry, my question is sometimes the challenge is how do one know that, okay, C1 or V1, this is the value for C1, this is the value for V1, based on the equation. Is there any explanation to that? So that when a question like this, I can know that, okay, V1, this is it, C2, this is it.
C1, this is the question given. You can take a good look at the question. How many liters of 10 molar? Part of what I explained earlier. I said molarity is the molar concentration. So what it means is mole per dm3, and that is its unit. It's the unit that will let you know that this is the thing given. It's the unit.
Okay.
So I'm going to snap this thing after this class. You take a good look at it inside the group. To learn easily like that. Know their unit. That is all. So far you know this thing molar. You should know it is concentration in mole per dm cube. If this one has liters or dm cube or cm cube, we know it is volume. It is the unit that will tell us what it is.
All
Sir,
right.
if I mention the length of this thing I'm using now, from this place to this place, it will be in meters or centimeters or feet or inches. So those are the units. Without the unit, I won't be able to say this is what I mentioned. These are what I mentioned. That is it.
Thank you.
So it is links that will make it easy for us to know what we're looking for and what we're giving. Okay, please, any question? Mr. Charles, you raised your hand earlier.
Yeah, please, I wanted you to, what this formula, you said, what's the name of the formula again?
Dilution formula. C1V1 equals to C2V2.
Okay,
it is the dilution.
Sorry, so it's safe to say that if we see a question where we are being asked to calculate the amount of liters it will take to dilute, a concentrated solution, this is the formula to use.
This is absolutely the formula. This is the only formula you use for that one. That's it. Thank you. Any other question, please?
Well, thank you.
You're welcome, sir. Okay, that's the question and that's the answer to it. So the next question we have here now, everyone has this question with them. It is what Osho sent now. Kodigi sent it for us. It is question 1. In a titration experiment, 21.60 cm cube of tetraoxosulfate 6 acid was required to completely react with 25.0 cm cube of caustic soda containing 2.0 grams of the alkali in 500 cm cube of solution. A. Write a balanced equation for the reaction. B. Calculate the concentration of I caustic soda in mole per dm cube. Calculate the concentration of tetraoxosulfate 6 acid in mole per dm cube. Calculate the concentration of tetraoxosulfate 6 acid in grams per dm cube. Are we all saying the question? If you are not saying it, please kindly indicate, signify rather. Signify if you are not saying the question, please. Okay. Oh, those that join the class later will not be able to see the question. Oh, okay. Okay. Can I share my screen?
No, Andre can screenshot. He can copy it and repaste.
I'm going to share my screen now. So this is the question. You can just screenshot it straight. This is the question. This is the question I'm reading out. The question I read out now. This is it. Are we all seeing it? I don't even know if someone is seeing it now because we have minimized.
Yes, we can see it.
Of
Good
course, we
evening.
can all see it.
So now I can't be writing with this thing now. I don't know if you are going to screenshot the question now.
Yeah, they should have
We
screenshotted it.
screenshotted it
Just
already.
proceed.
Okay, if that's the case, I minimize back. And I stop sharing my screen. And I open my camera. Okay. This is the stuff then. Jedidiah, yes sir, what do you have to say? Mr. Jedidiah.
No, I only see the file, don't see the question.
Eh? God. Okay.
Don't worry, let me copy and paste.
I've seen it. That was a error.
Perfect. That's good. Miss Biodun or Mr. What do you have to say? What do you have to say? Raise your hand. Thank you. Not okay, this is the question. We are going to work with it now. It says in a titration experiment. 21.60 cm cube of H2SO4. Note that thing first. That is the volume of H2SO4. Mr. Biodun or Miss Biodun, what do you have to say? You should know the rules. You're just raising your arm. Biodun or Motosho, what do you have to say?
Down your hand. We don't have time.
We don't have time for all this. All these things are just interrupting and you're not saying anything. Okay, so in a titration experiment, 21.60 cm cube. So that 21.60 cm cube absolutely means that is the volume, cm cube. So for the man that asked about it earlier, the way to recognize it is by knowing the unit. I've known that the unit is cm cube, the unit for volume. That's why I know it is volume. So the volume of the acid, that is 21.60 volume of acid. That is V of A, volume of acid. I will let my acid be A. So that's 21.60. I think you are going to remove some people here. 21.60 cm cube of H2SO4. So was required to completely react with 25.0 cm cube of caustic soda. We've known that our A is my thing showing my screen. Our A is H2SO4 and B is caustic soda, NaOH. So they said the volume of the B, that is, was required to completely react with 25.0 cm cube of caustic soda. That means volume of the caustic soda, that is VB equals to 25.0 cm cube. So containing 2.0 gram of the alkali means base, so that base, which is caustic soda, containing 2.0 grams of the alkali in 500 cm cube of solution. That is the mass amount of base, that is amount of the base in grams per cm cube. You know, it is in 500 cm cube. We have to make it grams per dm cube later. So, but for now, it is in 2.0 per dm cube, per cm cube, per 500 cm cube, per 500 cm cube. That will be 4 grams per dm cube. So, but let us calculate it out when it is time. So that is the amount of the base. Amount of the base is 2.0 grams in 500 cm cube. So now, number one, or the first question, write a balanced equation for the reaction. I repeat the question. In a titration experiment, 21.60 cm cube of tetraoxosulfate 6 acid was required to completely react with 25.0 cm cube of caustic soda. So tetraoxosulfate 6 acid, that is H2SO4, reacted with caustic soda, that is NaOH. Note one thing, the equation, the state of matter for caustic soda now is aqueous, they are acid. So aqueous is going to give, this is neutralization reaction. They will surely give salt and water. What is that salt? Na2SO4. That is sodium sulfate plus H2O. That is water. You have to look at your equation. Is it balanced? The equation I have here, I think it's not balanced yet. Okay, so I'm going to put 2 to balance my equation. I'm going to put 2 before caustic soda. So if you want to know balancing equation, you can go over it later. So we're not explaining balancing equation here. You shouldn't waste much of our time. So because the sodium here becomes 2, sodium here is 2. The oxygen here is 2 plus 4, that is 6. Oxygen here is still 1 plus 4. So I'm putting another 2 before this hydrogen 2. So I'm writing a balanced equation now. My hydrogen here is 4. My hydrogen here is 2 and 2, that is 4. My sulfur here is 1. My sulfur here is 1. My sodium here is 2. My sodium here is 2. My oxygen here is 4. And my oxygen here is 2 and 4. So that's 6. And here too it is 6. So please, any question first? Please don't ask me a question about how I balance the equation. So maybe if you come to my DM later about that, if I have time. Mr. M. Raise your hand.
Good evening.
Good evening. Please speak out.
All right. Please can you do a recap on how you balance the equation? And I can't actually see your screen.
How I balance the equation? Hey, I've said it that how I balance the equation, maybe later. That will not be in this class. We must not be diverting these things too much. You understand, sir? So maybe later. Maybe later. Maybe later. Sorry. Because of time. Because of time. So anything?
Oh, don't worry, I've seen it. It has been balanced. I'm
It has been
saying
balanced.
one thing.
It's a balanced equation.
Yeah, you've balanced
So
it. It's fine.
Mr. N, to be nice with you, H2SO4 is the acid, and caustic soda is the base. The both of them are going to react to give salt, that is Na2SO4, and water. So now, to balance the equation, there is a simple way. Just write your hydrogen out. Hydrogen, how many hydrogen do you have here? Write your hydrogen out here too. Write your sulfur out here. Write your sodium out here. Write your oxygen out here. The same thing here, the same thing here, the same thing here. So here now, how many hydrogen do I have? 2. I have 2 hydrogen with this one. So the hydrogen becomes 3. But I'm not write it as 3 straight. I'm writing 2 plus 1. This is the hydrogen I have in this compound. So in this one now, I have just 2 hydrogen. 2. I suppose the man is saying me now, Mr. M. Or what's his name? Is M. So now the next one is sulfur. How many sulfur do we have here? Just 1. I'm writing the 1 out. How many sulfur do we have here? Just 1, 2. I'm writing the 1 out. Sodium. How many sodium do we have here? Nothing is before it. Sodium is still 1 for now. And sodium here has 2 at the base. So sodium is 2 here. Part of why we have to balance the equation. Oxygen here is 4 and 1. 4 in this compound and 1 in this compound. That is 4 plus 1. So an oxygen here is 4 plus 1, 2. So I can say the hydrogen here is 3, while the hydrogen here is 2. I have to make these things balance. Let me say I'm going to add 2 hydrogen here to make this hydrogen 4. That means I'm multiplying it by 2 because I put it at the front. So this is 4. I'm putting 2 hydrogen at the front of this one too. I'm not happy as I'm diverting this attention. We are supposed to finish that thing we are into first. We are writing a balanced equation for the reaction. Okay, let's consider it as we are answering the first question. So anyone should ask me a question about it then. So since we are already taking it, any question about it should be asked. So now the sodium has become 2 here. So I have to multiply it by 2. The hydrogen 2, which is 1 before, or which was 1 before, has become 2 now. So I have to multiply this 1 that I wrote for this hydrogen in this compound by 2. Hydrogen here becomes 4. Hydrogen here becomes 4. So sodium here becomes 2. And sodium here was 2 before. So now oxygen here becomes 2 plus this 4. That is, oxygen becomes 6. So because this one has been multiplied by 2, oxygen becomes 6 here. And oxygen is still 4. Okay, it has also become 6 here too. So the equation is balanced. This is 2. This is, I'm sorry, 2 plus 2. This is 4. This is 4. This is 1. This is 1. This is 1 times 2, 2. This is 2. This is 4 plus 2, 6. And this is 6. So the equation is balanced. That's how we balance the equation. I'm listening. Any question? Can kindly come to the group if you don't understand balancing equation. People will surely put you through. Kindly come to the group later. Okay, if that's the case, we continue with our questions.
Ali, sorry for saying this. You don't have choice. I think we'll finish this class by 11 because you've not started anything.
We are playing, bro. I tell you, come to it. I'm telling you, I tell you, come up for you. Hope now is even here, Sha. Okay, we go now. Now, name my first. I do it, my dear. Okay. So B is the next thing. So we've answered the first question. That's H2SO4 plus caustic soda is going to give now 2SO4 and water. So the water is steam now to write the state of reaction, the state of the compounds, state of matter. This one is aqueous, and the water is not just water now, it will go out as steam. It's gaseous water here. So you can come to ask for that later if you don't understand. So B is the next question. Let me see from the question given. B says, calculate the concentration of NaOH in moles per dm3. Concentration of NaOH in moles per dm3. So concentration of NaOH in moles per mole per dm2. That's what we are looking for. But we cannot just get this thing without knowing its concentration in grams per dm3, because that was given before. So now we have to get it first. Concentration of caustic soda in grams per dm3 equals to mass of caustic soda over, I've written this formula out before. I said we call it normality. That normality is the mass concentration. That's the mass of that compound, mass of that caustic soda over volume in dm3. What did you say? The H2O. I think the H2O, this thing is covering it. The H2O that are the product should be liquid. No, because this one is steam, it's not liquid. The H2O it's gas, it is steam. This one is not water, it is steam that is produced. You can ask about that later. It is steam, sir, or ma, the person that wrote it out. It is steam. Okay, so now mass of the compound, mass of the compound over volume in dm3. That is the formula for normality. Before we get our molarity, we have to use normality here. So we have to be normal before we are molar. That's what they are trying to say here. So mass of caustic soda over the volume of caustic soda in dm3. Look at the volume given to us. The volume was given in cm3. That is 500 cm3. To change it to DMQ, that will just be 500 divided by 1000. So that's 0.5 DMQ. 0.5 DMQ. So concentration, please ask any question if you don't understand it. Please. Concentration of NaOH in grams per DMQ is going to be mass of NaOH. That is, the mass given to us was 2. Keep looking at the questions. 2 grams over volume in DMQ. That's 0.5 DMQ. So this one now is going to be 2 divided by 0.5. That is 4 grams per DMQ. We've gotten the normality first. This concentration in grams per DMQ. So we are going to use this thing now to get the concentration in moles per DMQ. So now the concentration in moles per DMQ, we call it molarity or molar concentration. Molar concentration equals to mass concentration over molar mass. Now, I don't know if many of us have the molar mass before or we don't have it before. So the molar mass, you have to calculate it out yourself if you don't know it before. The molar mass of the thing, write the compound out first. The molar mass is also known as the formula mass. Write the compound out first. Sodium, everything is given at the end of the question. You can check it there. Sodium is always 23. We are using the mass number. Mass number of sodium is 23. Plus oxygen is 16. Plus hydrogen is 1. So this is going to give us 40 grams per mole. So that is the mass, molar mass of caustic soda. So we are using mass concentration. That's the mass concentration we got was 4 over molar mass. The molar mass we got is 40. So we got 4 over 40. Doing the mass now, we're going to have 0.1 mole per DMQ. There's a question someone wants to ask me now, I suppose. So the question is that, why do I know it is mole per DMQ? It is because we are looking for the concentration in moles per DMQ. We are looking for the molar concentration. We are looking for the concentration in moles per DMQ. So that is the molar concentration. So please, any question first? Don't feel shadow in your cover. Any question? Any question from anyone? Hey, so nobody understood this thing. Kai. So,
okay, good evening, everyone.
Good evening. What's your question, please?
Well, my own is not that really question. I need a favor. Can you help us screenshot this solution and place it on the group chat? Because my if it is network, I can't see. I
Any
can't
question,
see
please?
very well. If you can screenshot it and send it to the group.
This is it. I'll snap and send it to you. But this is it. You can see it well now.
All right, thank you.
Welcome. What's your name? Okay. Any question from anyone? I think no one has any question. Okay, if that's the case, we'll continue then. So, molar concentration is what we've gotten here right now. Let me explain again. I said concentration of caustic soda in moles per DMQ is what we are asked to look for. That is the molar concentration. So, but before getting it, since we are not using that CAV, then over CBV, DMV, so we have to do what? We have to get the concentration in grams per DMQ first. Because we are given the mass to be 2, we are given the volume to be 500. So 2 grams in 500 cm3, that is going to be 4 grams in 1000 cm3. That is 4 grams in 1 DMQ. I'm going to snap this and send. So anyone you don't understand, and moreover, the video will be out. That is another grace. The video will be out, which Kingsmith is going to paste on the group for us. So that the molar concentration equals to mass concentration over the molar mass. What is the mass concentration we got? That was 4 grams per DMQ. The molar mass is by adding the mass number of all the components of that compound. What's the compound? Caustic soda. The mass number of the component will be mass number of sodium, that's 23. Mass number of oxygen, that's 16. Mass number of hydrogen, that is 1. Adding them together, we are going to get 40. So molar concentration, that is concentration in moles per dm cube, is going to be mass concentration, that is 4 over molar mass, which is 40. 4 over 40 is going to give us 0.1 moles per dm cube. So this is B. We've answered the second question. Okay, we keep going then. C is the third question. So the next thing is okay, BII. That is the concentration. Concentration of H2SO4 in moles per dm cube. So since we have the concentration of the base in mole per dm cube now, we know the equation of the reaction and we have their volumes. So we can definitely use the concentration formula. So that formula is CAVA over CBVB equals to NA over NB. Please take a look. This is the formula we are using. We have our CA. This is this. Okay, we don't have our CA. That is what we are looking for. CA is question mark. But we have our CB to be this. Concentration of B to be this 0.1 moles per dm cube. We have the volume of A from the question given. That is 21.60. Volume from the question given, 25.00. And we have the number of moles of A. A is the acid. So number of moles of A is just 1. Because we didn't write anything there, it is 1. The number of moles of B is 2. Number of mole of that compound in the reaction. That is what we mean. So now we are looking for the concentration of A. So making Ca the subject, Ca is going to be CbVbNa over VaMb. If you do your maths, you are going to get this. So what is the Cb? Cb is the concentration of base in moles per dm cube, not grams per dm cube. Moles per dm cube. We are coming to look for the concentration in moles per dm cube. That's 0.1. So 0.1 multiplied by what is the Vb, volume of the base that is pipetted against the acid. That was 25.0 cm3. That's 25. I said cm3. That's cm3. So times number of moles of A. You come to look at your equation. What is the number of mole of A? That is just 1. This is 1:2. So multiplied by 1 over volume of A. That is the volume of the acid. I'm coming here to check that out. That is 21.6. 21.6 times what is the number of moles of the base? I come here to check that out. That is 2. So I write the 2 out. So we have 0.1 times 25. That is 2.5 times 1, 2.5 over 21.6 times 2. That is 23.2. So anyone to do the mass, 2.5 divided by 23.2 will be the concentration of H2SO4 in mole per dm cube. So please, anyone to do the mass? 2.5 divided by 23.2. That's funny.
0.1.
0.1.
0.11. I approximated is 0.107.
Sorry, the denominator has to be 43.2. 0.107.
0.107.
Okay. 0.107. So it's better to leave it this way. These 3 decimal places as it is. So moles per dm.
It's 1.6 times 2 is not 23.2 now.
Where?
Yes, that's what I wanted to say. It's 43.2.
Supposed to be 43.2.
Sorry. I thought I wrote 43. That was what that's in my mind though. I'm sorry everyone. I thought I wrote 43. That's a simple mistake. Yeah, thank you very much for that notification. 2.5 divided by 43.2 then.
That's 0.5 divided by
0.58.
7 or 8.
0.8.
0.05.
0.0578.
Okay. Moles per dm cube. So 0.0578 moles per dm cube is the concentration of the acid, that is the A, tetroxosulfate 6 acid, in moles per dm cube. We've solved the next equation now. So the next question rather, we are looking for the next question. That should be III. So III is the concentration of H2SO4 in grams per dm cube. That is normality of H2SO4. Concentration of H2SO4 in grams per dm cube. So to do this one now, we are going to use that formula that connects concentration in mole per dm cube, molar mass, and concentration in grams per dm cube. What's the concentration in mole per dm cube? 0.0578. So we are writing that out first. Concentration in mole per dm cube. That's 0.0578 mole per dm cube. What's the molar mass? We are going to calculate that out. I suppose we are getting 96 or something. Hydrogen is 1 for the molar mass times these 2 that is at the base of hydrogen. 2 atoms of hydrogen are there. So 1 times 2 plus sulfur is 32. We are using the mass number here. Plus oxygen is 16 times the 4 that is here. That is 4 atoms of oxygen. So now we have 2 plus 32 plus 64. We are going to have 98 grams per mole. So and then 96. So it is 98 grams per mole. That is the molar mass of this H2SO4. So we have the concentration in moles per dm cube already. So if you can recall a formula we used when we wanted to get the concentration of NaOH in moles per dm cube. We said concentration of NaOH, concentration of H2SO4 now in moles per dm cube equals to concentration of this same H2SO4 in grams per dm cube over molar mass of this same H2SO4. Ms. Abigail, any issue? Raising your hand. You are raising your hand. Is there anything you want to say? You are raising your hand. Is there anything you want to say? Okay, nothing. If that's the case. Okay. So now, don't forget that we are looking for the concentration in grams per dm cube. We already have this one in mole per dm cube. And we already have the molar mass. We are looking for the concentration in grams per dm cube. So let's come back and write concentration in grams per dm cube. We are making it the subject here now. Is equal to concentration in mole per dm cube. You understand, by cross multiplying times, thank you, the molar mass. So what is concentration in mole per dm cube? The one we got earlier. That was 0.0578 multiplied by the molar mass. We had 98. Any mathematician? Sorry, any calculator?
$5.67.
Perfect. So 5.67 grams per dm cube is the concentration of H2SO4 in grams per dm cube. This is what we just did. Okay. We keep going, and the next one would be.
I calculated my own 5.6644.
5.6644.
6644.
66. So it's okay. It's okay to write 67 now. 66. So 66. Just take it as 66.
5.6.
Okay, you said 6 is 1 4. Eh.
Yes.
Will you calculate again? Will you calculate again?
No, it is 5.5.
Yes.
Okay, 6 is 4.
I got the same thing. 5.6644.
Okay. So we are going to change. We are going to change to 5.6 grams per dm cube. Then.
Can we use 5.7?
Yes, you can use 5. That is even the best thing because they always leave this one mostly in one decimal place like this. 5.7 grams per dm. I prefer it this way. It looks handsome. Maybe that's what the person even wanted to say. The person that gave us the answer. Maybe he wanted to approximate, but he mistakenly said 5.67. I think that's what the person wanted to say. Okay, so we've gotten the mass concentration now. Are we here now? Okay, the next question will be what could it be? I think that's all. We've calculated the tetraoxosulfate 6 in mole per dm3, the H2SO4 in moles per dm3, and the H2SO4 in grams per dm3. I'm going to screenshot this thing and send into the group. So, Prodigy, if it was a bet, I want the bet now. Mr. Bamikoli, anything,
What do you
sir?
say?
I'm coming. Mr. Bamikoli, anything? Kindly speak out. Okay, all of them are just raising their arms. They are not saying anything.